Have you ever felt like the moon still holds secrets we can barely comprehend? Japan's Moon Sniper mission has unveiled a discovery so startling it's left renowned astrophysicist Michio Kaku in a state of shock. As the fifth country to land on the moon, Japan's breakthrough could revolutionize our understanding of space. Why is Michio Kaku terrified, and what did Japan uncover? Dive in as we explore the chilling secrets unearthed by Japan's lunar mission. Chapter 1. Slim Mission Breakthrough. On January 19, 2024, the Japan Aerospace Exploration Agency JAXA accomplished an extraordinary feat. They successfully guided their specially crafted probe SLIM to touch down gently on the surface of the moon. This achievement is significant as it positions Japan among a select group of only 5 nations to accomplish such a remarkable feat in lunar exploration. The journey leading up to this momentous event traces back to 2005 when JAXA embarked on the development of a small satellite aimed at conducting experiments on the lunar surface. Over time, SLIM grew into a major mission and eventually became part of the goals of the International Space Station by 2013. In April 2016, the project was officially named as a JAXA mission, and Mitsubishi was given the responsibility to build the spacecraft. The primary objective of this mission, as noted by Michio Kaku, was to try out a creative landing technology. One of SLIM's most notable achievements was its journey duration of approximately 4 months, commencing alongside the Gray Imaging and Spectroscopy mission XRISM. Separating from XRISM, SLIM charted its course toward lunar orbit, successfully entering it by December 25, 2023. The touchdown on the moon was praised as one of the smoothest ever, showing how careful planning and clever technologies made it possible. Kaku explains the challenges associated with lunar landings, which prompted the development of the Smart Lander for investigating the moon. SLIM, an innovative idea that uses brand new technology to land with extreme precision. The success of this mission not only shows that we can land on the moon with incredible accuracy, but also hints at exciting possibilities for exploring other planets and moons in the future. Kaku emphasizes that space agencies like NASA are no longer content with merely landing anywhere on the moon. The focus now lies on landing precisely at designated locations. Fortunately, on January 19, 2024, the mission reached a breakthrough moment as the lander executed a flawlessly soft landing precisely where intended, marking a significant leap forward in our quest to unravel the mysteries of space. Chapter 2. Evolving Precision in Lunar Exploration. Numerous recent attempts to land on the moon have failed, with spacecraft crashing in locations other than their intended targets. For example, shortly after facing a major problem, a private U.S. spacecraft on a mission to the moon ended in a dramatic way by purposely breaking apart an Earth's atmosphere. The lander, known as Peregrine, was developed and managed by the Pittsburgh-based company Astrobotic. The company had a goal to do something really new, to be the first to softly land a commercial spacecraft on the moon's surface. One's mission was part of NASA's Commercial Lunar Payload Services (CLPS) initiative, which encourages private enterprises to construct and operate lunar landers for delivering NASA equipment and instruments to the moon. Peregrine began its journey in the early hours of January 8, 2024, riding on the very first successful flight of a United Launch Alliance Vulcan Centaur rocket. Plated with 6 NASA instruments, a variety of payloads including a Lunar Library Archive human remains and lunar rovers, the spacecraft soared into the sky. However, shortly after separating from its launch vehicle, Peregrine encountered a fuel leak, causing chaos in its propulsion system. Astrobotic believes that a problem with a valve caused a sudden rush of high-pressure helium to flood into Peregrine's fuel tank, eventually causing it to rupture. The propellant escaping into space acted like a surprise rocket, which could have sent the spacecraft spinning out of control in a dangerous way. Swift-thinking engineers at Astrobotic sprang into action, utilizing Peregrine's small control thrusters to counterbalance the escaping propellant. This maneuver successfully stabilized the spacecraft, allowing its solar panels to align with the sun for recharging onboard batteries. Nevertheless, Peregrine had already lost too much propellant by this point to safely attempt a lunar landing. Following the mishap, Astrobotic was determined to prolong the mission's duration, surpassing the company's initial expectations. As the pressure inside the damaged tank gradually decreased, the leak subsided, extending Peregrine's operational capabilities. By January 9, Astrobotic estimated that Peregrine still had 40 hours worth of propellant remaining. 3 days later, this estimate increased to 52 hours. By January 15, the leak had nearly ceased, as stated by the company. Peregrine continued its journey towards the Moon's vicinity, reaching a distance of over 242,000 miles from Earth on January 13th. Initially, the plan was for the spacecraft to first circle back towards Earth before heading out to meet up with the Moon. However, on January 14th, after consulting with NASA, Astrobotic opted to minimize space debris by allowing Peregrine to burn up in Earth's atmosphere. Based on the latest telemetry data received from Peregrine, Astrobotic officials estimate that at around January 18th, the lander broke apart in the skies above the South Pacific Ocean, approximately 1,500 miles off the eastern coast of Australia. Setting the bar for Lunar Explorations, SLIM executed a careful descent, allowing the rovers to be safely deployed onto the lunar surface. If a rocket were to lose one of its engines mid-flight, it could result in a catastrophic crash or, in the best-case scenario, an emergency landing nearby. Despite facing a nozzle loss, SLIM managed to land perfectly on target. Michio Kaku emphasizes that Japan's impressive achievement has boosted its status among countries exploring the Moon. This shows their skill and dedication in space exploration, setting a tough benchmark for upcoming missions. In the 21st century, only China has achieved successful moon landings. This has prompted questions about why modern moon missions encounter difficulties with landings when NASA accomplished it 50 years ago. During the space race, there's a belief that the US and Russia were in intense competition to show who was better. This led to NASA spending a lot on exploring the Moon with strong support from the US government. However, in today's era, without a space race, lunar missions are primarily driven by curiosity or the pursuit of historical recognition. Consequently, modern probes and vehicles often employ cheaper materials to cut costs. Additionally, many spacelanders are now developed by private companies rather than government agencies, which can impact their quality, reflecting the evolution of space exploration. Speaking of private companies, statistically, their lunar landers have failed each time. Another challenge for landers and probes stems from the Moon itself. Communication is challenging due to the Moon interfering with radio signals, causing probes to land off-target. Furthermore, the absence of air on the Moon complicates landing maneuvers. Parachutes don't function the same way as they do on Earth, making the craft's engine the sole means of control. Pilots have to deal with these obstacles and also face challenges like disruptions in communication. If the probe is too heavy, it risks crashing. China's Chang'e 3 mission in 2013 marked the first successful soft landing on the Moon since Russia's Luna 24 in 1976. Many other countries like Russia have attempted and failed moon landings, signaling a need for change to address these landing challenges. Fortunately, Japan has devised a solution that could change lunar exploration, offering optimism for more successful landings and advancements in space exploration. The Japan Aerospace Exploration Agency JAXA, known for its close collaboration with NASA, has introduced an innovative guidance system that holds great promise for upcoming NASA missions, such as the Artemis program aimed at returning humans to the Moon. However, the significant issue that arose with SLIM's landing on the Moon has left JAXA engineers perplexed. Despite careful design to ensure an upright landing, SLIM unexpectedly touched down face down, presenting a significant challenge. Experts are now pondering the possible causes behind this anomaly. Michio Kaku suggests that until this puzzle is solved, future NASA missions could be endangered. Understanding the circumstances surrounding SLIM's landing is crucial for ensuring the success of future lunar missions. Presently, the specifics of SLIM's landing remain covered in mystery, prompting intensive efforts from JAXA and NASA scientists to unravel the mystery. Solving this mystery is really important to make the most out of exploring the Moon and to make sure that future missions are safe and successful. SLIM was carefully engineered for precise landings, equipped with specialized legs featuring crumple zones similar to safety features in cars designed to facilitate soft landings even at high speeds. The designated landing spot for SLIM was a precise location within the Ashley crater, featuring a slope of 15 degrees. JAXA engineers calculated the exact coordinates, aiming for a slope of 25.24% at the landing area. To facilitate a smooth landing, SLIM was equipped with back legs shorter than its front legs. Additionally, just before the touchdown, SLIM was programmed to execute a precise 45-degree flip to reduce the impact. Regardless of its weight, SLIM was outfitted with 2 Mitsubishi engines and 12 attitude control thrusters commonly found in lunar probes to ensure gentle landings. These thrusters played a crucial role in controlling the descent speed and maneuvering during landing. The landing process was divided into 2 stages. Initially, the landing thrusters and a smaller thruster would adjust the spacecraft's tilt, followed by the utilization of 5 crushable aluminum lattice landing legs to cushion the final impact. Despite the careful planning and advanced technology employed, SLIM unexpectedly landed on its nose, surprising scientists with an unexpected outcome. Chapter 3. Challenges of Jax's mission. During its journey to the lunar surface, the SLIM mission encountered an unexpected obstacle, a glitch in one of its engines. This glitch posed a threat to the mission's success. As SLIM descended towards its landing site, one of its main engines suddenly experienced a decrease in thrust. This unexpected event raised concerns among mission controllers and engineers. The engine anomaly occurred when SLIM was approximately 50 meters above the lunar surface during the final stages of its descent. Onboard sensors detected the sudden reduction in thrust, triggering an automatic response from the spacecraft's guidance and control systems. Despite the anomaly, SLIM continued its descent towards the lunar surface, but with reduced propelling force. Upon closer examination, mission engineers determined that the engine anomaly was caused by a malfunction in one of the engine's nozzles. The exact reason for the nozzle problem wasn't clear right away, but it might have been because of a valve problem or an issue with the fuel mixture. The loss of thrust from one of the engines led to an asymmetric or off-balance descent profile, resulting in deviations from the planned landing trajectory. Despite the engine anomaly, SLIM's onboard systems successfully managed the situation and adapted to the reduced thrust conditions. The spacecraft's guidance and control systems adjusted its orientation to compensate for the asymmetric thrust, allowing SLIM to maintain a controlled descent toward the lunar surface. As SLIM got closer to landing, the engine issue became more noticeable, causing it to land a bit off target and tumble when it touched down. Ultimately, the spacecraft landed with its solar panels facing westward, posing challenges for power generation and mission operations. As a result, SLIM couldn't recharge its power supply. To cope with the power issue, Jaxs' team resorted to backup batteries and swiftly dispatched 2 rovers to investigate the moon's surface. At the same time, the multiband spectroscopic camera NBC aboard SLIM snapped some photos. These images provided crucial insights into the lunar terrain. Meanwhile, Michio Kaku explains that upon analyzing the NBC data, Jaxs determined that the lander had not sustained significant damage, bringing a sense of relief to the team. In response, Jaxs decided to deactivate the lander and await a change in the sun's angle. A day on the moon is way longer than a day on Earth, lasting about 14 Earth days. This means the moon goes through long stretches of sunlight and darkness. This big gap in time between the moon and Earth makes exploring its surface a real tough challenge. Initially, Jaxs intended to power SLIM using solar energy for a minimum of 2 weeks. However, when faced with the unexpected landing issue, they chose to wait until the lunar day ended. Once the sun's rays aligned properly with the solar panels, Jaxs could utilize the collected energy to operate SLIM. This strategic decision demonstrates the adaptability and patience required for successful lunar exploration. As sunlight began reaching the west side of the moon, the solar panel gradually started producing power again. This allowed SLIM to automatically restart its operations. Jaxs shared their success in reestablishing communication with SLIM via the social media platform X. Operations resumed, enabling the lander to capture and transmit new images of the lunar surface using its multiband camera. Among these snapshots was a close-up of a peculiar rock near the lander, affectionately called Toy Poodle by the team at Jaxs. Another picture displayed a patchwork view of the moon's surface decorated with rocks of different sizes and shapes. Jaxs scientists added some humor by giving them amusing nicknames like Shop Dog, Pomeranian, and Shih Tzu. These pictures offer insights into the diverse lunar terrain surrounding the Schley crater, shedding light on the lander's precise location and current condition compared to recent failed missions. Chapter 4. Unraveling SLIM's Mystery. SLIM's surprising touchdown ignited widespread speculation, capturing the attention of both scientists and the general public. Some pondered the involvement of external forces, suggesting that factors beyond human control might have influenced the probe's descent. SLIM even came up with imaginative theories suggesting the possibility of aliens getting involved, imagining scenarios where beings from another planet affected the mission's result. The unexpected twist in SLIM's landing introduced a new layer of puzzle to the mission, leaving Jaxs scientists and engineers confused as they tried to unravel the mystery. Despite careful planning and design, the probe appeared to veer off course from its intended landing spot, prompting thought-provoking inquiries into the mysteries concealed within the lunar landscape. Rumors about outside forces or alien involvement added an interesting twist to the story, highlighting the need for a careful investigation to find out what really caused Slim's unexpected behavior. While some entertained notions of extraterrestrial involvement, such claims remained speculative, lacking solid evidence to support them. For Jaxs scientists, the task at hand presented a unique challenge requiring careful analysis of mission data and circumstances to solve the mystery surrounding Slim's landing. As the probe rested on the moon's surface, its solar panels oriented westward in anticipation of the next sunrise. Jaxs intensified its efforts to shed light on the situation, adding further complexity to the puzzle. This quest for comprehension not only fascinated scientists but also thrilled space enthusiasts worldwide, eager to unravel the secrets hidden within Slim's unexpected descent. In order to grasp the full scope of what occurred, Jaxs aimed to acquire satellite imagery, potentially from sources like NASA's Lunar Reconnaissance Orbiter, to gain a clearer understanding of the situation. Even though it didn't land where planned, Slim still managed to achieve some goals by releasing 2 experimental rovers and using its scientific gear as much as it could before running out of battery. These rovers, known as Lunar Excursion Vehicles, LVEs, possessed unique characteristics. LVE-1 resembled a frog and moved by hopping, while LVE-2 took the form of a small ball and transformed into a wheel camera that explored the lunar terrain like a sea turtle on a beach. Incredibly, LVE-1 successfully established communication with ground stations and even received a test radio signal from LVE-2, showcasing the adaptability and functionality of the rovers and providing valuable insights for future lunar exploration endeavors. Despite this progress, Jaxs has yet to receive any images from LVE-1. It was LVE-2, now named SORQQ, that captured an image of Slim on the moon. It's fascinating to note that the picture showed Slim's thrusters pointing upwards, which is the opposite of where they were supposed to be. Both rovers waited in standby mode for the return of sunlight to power them up. According to estimates, this was anticipated to occur around January 31st, marking the end of the lunar day. It's worth noting that the construction of the Slim spacecraft incurred significant costs amounting to approximately 18 billion yen, equivalent to about $120 million. Initially weighing 200 kilograms, its weight surged to 700 kilograms when fully fueled for landing. Developing the LVE-1 and LVE-2 rovers presented its own set of challenges and financial expenses. Specifically, LVE-2, now called SORQQ, is extremely intricate despite its tiny weight of only 0.25 kilograms. It holds the title as the smallest and lightest rover ever made, roughly the size of a baseball. Crafted by Jaxs Sonitomi and Doshisha University, SORQQ merges elements of toy technology, sensor robotics, and space expertise from Jaxs. Engineered to function independently and adapt to the lunar landscape, SORQQ stands as a remarkable feat of engineering. Shinichiro Sakai, the project manager for Slim, hailed the mission's success, remarking, "We've demonstrated the capability to land wherever desired, not merely where possible." He envisions that this success will fuel aspirations for future Japanese lunar missions to venture into unexplored lunar territories. This technological breakthrough marks a significant achievement for Japan's space agency and could pave the way for further exploration of the moon's far side using probes, rovers, or even human astronauts. Additionally, was Japan's lunar mission solely focused on advancing planetary landing technology, or did it harbor broader objectives such as harnessing solar power from space? Now it's time for today's subscriber pick. Michio Kaku's pulse quickened as he scrutinized the monitor displaying Japan's latest lunar mission images in his lab. The team had unearthed an astounding find on the moon's surface, stirring both exhilaration and dismay in Kaku. Amid the barren lunar expanse, structures with an ethereal shimmer and intricate designs carved into the moon dust emerged. Kaku pondered the origins of these towers stretching skyward. Were they the remnants of an ancient civilization erased by time, or signs of extraterrestrial activity? His enthusiasm was palpable, yet so were his reservations. The discovery's implications for humanity loomed large. It promised a new dawn of exploration and insight, but also threatened to challenge our cosmic comprehension. As the reality of Japan's startling lunar observations sank in, Kaku recognized the inception of a journey. The moon's enigmas were profound, promising endless secrets to unveil. With each groundbreaking revelation, the world awaited breathlessly ready for the next leap in our stellar odyssey. Would Japan continue to defy expectations in their lunar investigations? Share your theories in the comments below. Chapter 5. Paving the way for future collaborations in space. In contrast to past lunar missions like NASA's Apollo program in the 1960s and 1970s, SLIM represents a more cost-effective and technologically advanced approach to exploring the moon. While the Apollo missions relied on manned spacecraft and basic lunar landers, SLIM is an unmanned mission that uses independent navigation and landing systems to achieve precise landings on the lunar surface. This transition to unmanned missions reduces costs and eliminates the risks associated with human space travel, allowing for more frequent and economical lunar exploration missions. SLIM's advanced guidance and control systems enable it to land precisely within designated target areas, a capability that was not achievable during earlier lunar missions. For example, the Apollo missions relied on manual piloting and navigation techniques, resulting in less accurate landing locations and limited surface exploration capabilities. SLIM's ability to land precisely and deploy scientific instruments and rovers enhances its scientific capabilities, enabling more comprehensive investigations of the lunar surface. Its scientific objectives and payload complement those of previous lunar missions, providing continuity in our exploration and understanding of the moon. In the past, missions mostly looked at basic rocks and explored the surface. But SLIM is different. It's equipped with high-tech tools and sensors to study the makeup, layout, and unique features of the moon's surface in much more depth. This thorough way of exploring the moon adds to what we've already learned from past missions. It helps us get a better grasp of how the moon was formed and how it's changed over time. The success of Japan's SLIM mission opens up exciting prospects for future collaborations in space exploration, paving the way for continued advancements and discoveries in our exploration of the cosmos. In the last few years, space agencies working together has become more and more common. They've realized that pooling their resources and knowledge can help them make new discoveries faster and achieve their goals in space exploration more effectively. SLIM's accomplishments, along with Japan's established partnerships with international space agencies like NASA and the European Space Agency, ESA, lay a strong groundwork for future collaborative endeavors in space. One of the most promising avenues for future collaborations is NASA's Artemis program, which aims to send humans back to the moon and establish a sustainable lunar presence by the end of the decade. Japan's expertise in lunar exploration, showcased through the SLIM mission, positions it as a valuable partner in the Artemis program. By contributing technology, scientific instruments, and logistical support, Japan can play a crucial role in achieving the goals of Artemis and expanding humanity's presence beyond Earth. SLIM's success highlights the significance of international cooperation in tackling complex challenges and unlocking the full potential of space exploration. When countries team up on projects, they can split the costs, take on risks together, and share the rewards. This makes big missions like sending people to the moon and exploring deep space easier to do and less expensive. By forging partnerships with other spacefaring nations, Japan can harness collective expertise and resources to pursue ambitious goals in space exploration, such as crewed missions to Mars and beyond. In addition to government-led collaborations, there are opportunities for collaboration between space agencies and private companies. Jaxs, Japan's space agency, has been actively partnering with commercial space companies, such as SpaceX, showing its willingness to collaborate with the private sector. By teaming up with these private companies, Japan can access innovative technologies, launch capabilities, and funding sources that complement its strengths in space exploration. Chapter 6. Pioneering diversity in lunar exploration. NASA and its partners are starting a groundbreaking mission to reach a major goal for humanity: landing the first woman and the first person of color on the lunar surface as part of the Artemis program. After 2 test missions, Artemis 3 is set for 2026 and will mark the first human presence on the moon in over 5 decades. This mission is particularly historic as NASA intends to send astronauts to explore the area near the lunar South Pole, an unexplored region. Michio Kaku likens NASA's Orion spacecraft to a futuristic taxi for astronauts, shuttling them from Earth to the moon and back again, navigating through lunar orbit. What makes Orion remarkable is its capability to safely transport astronauts back to Earth at incredibly high speeds during re-entry from the moon. Four astronauts are slated to launch from Launch Pad 39B at Kennedy Space Center in Florida atop the Space Launch System SLS, the sole rocket with sufficient power to propel Orion, the crew, and their equipment to the moon in a single trip. What's equally thrilling is the diversity within the astronaut team, each member bringing their unique skills honed through extensive training for this mission. The crew's journey begins with orbiting Earth, ensuring all systems are functioning flawlessly and fine-tuning Orion's solar panels. With a mighty boost from SLS's temporary cryogenic propulsion stage, Orion commences its journey to the moon through a maneuver known as a translunar injection. During the journey, the crew will make minor engine adjustments to maintain the correct trajectory. Upon reaching the moon, Orion will enter a lunar orbit known as a near-rectilinear halo orbit (NRHO), carefully selected by NASA from numerous options due to its alignment with the long-term objectives of the Artemis mission. NRHO allows constant communication with Earth and easy access to all regions of the moon while conserving fuel efficiently. Fortunately, NASA has entrusted SpaceX with the construction of the spacecraft responsible for transporting astronauts between Orion and the lunar surface. SpaceX plans to conduct extensive tests and unmanned flights to ensure the safety of the spacecraft before astronauts embark on their historic journey. Before the astronauts embark on their lunar journey, SpaceX will dispatch a large tank of fuel into space. Using specialized ships, additional fuel will be transported to the tank in space. Subsequently, an unmanned spacecraft will launch into space and meet with the fuel tank to refuel. Once replenished, the spacecraft will travel to a designated location near the moon and await the arrival of the astronauts. When both the spacecraft and the Orion capsule are close to the moon, they will dock together. 2 astronauts will transfer to the spacecraft designed for lunar landing, while the other 2 will remain aboard the Orion. The Orion will then move away and remain in lunar orbit for approximately 6.5 days, the duration of the astronauts' stay on the moon. Chapter 7. From lunar landings to Mars exploration. Jaxs has been getting noticed all around the world by building strong relationships with respected partners such as NASA and the European Space Agency. It played a vital role in constructing the International Space Station (ISS) and is now contributing to the development of modules for the Gateway Luna station, solidifying its reputation as a dependable collaborator in space exploration. Amidst these achievements, Jaxs is planning big missions. The Slim landing mission marks just the beginning. Jaxs is gearing up for a journey to Mars with its Martian Moon Exploration spacecraft scheduled to launch in 2024. This mission aims to study the Martian moons, collecting samples and data to enhance our understanding of Mars. For this mission, Jaxs will utilize its powerful H3 launch vehicle. This new rocket uses liquid oxygen and hydrogen as fuel. It has 3 engines in the first stage and 1 in the second, making sure it moves forward efficiently. Despite facing challenges during the first launch of the H3 rocket in 2023, Jaxs remains undiscouraged, planning another flight in 2024 with hopes for success. Furthermore, Jaxs is working on New Glenn, a larger project aimed at exploring Mars. Standing at 98 meters tall, New Glenn is a potent booster with 7 engines in the first stage and 2 in the second. Its first flight is scheduled for around August 2024, carrying NASA's ESCAPADE-MS mission. These advancements underscore the thrilling possibilities in space exploration, with Japan's innovative landing technology and NASA's expertise promising an exciting future of space missions. Thanks for joining our journey today. There's so much more on the horizon. Consider this your personal invitation to our next adventure. Until then, take care.